Welcome to March 15th LeetCode Challenge. Minimum remove to make valid parentheses. Given a string of given a string S of the open parentheses and close parentheses and lowercase English characters, your task is to remove the minimum number of parentheses, such as this or this, in any position so that the resulting parentheses string is valid and returns any valid string. Formally, the parentheses string from a parentheses string is valid if and only if it meets these three conditions. It is an empty string that contains only lowercase characters. It can be written as A, B. A can concatenate with B, where A and B are valid strings, or it can be written as A open parentheses, A close parentheses, where A is a valid string. So given this input here, example 1, we see in order to generate the valid to remove the minimum, to remove any parentheses to make a valid parentheses, we have to basically remove the ending parentheses. So that if we remove the ending parentheses, we would have everything being a valid parentheses, such that C is enclosed, it is enclosed by these two. Also note that if we were to remove this parentheses here, it would also be valid, given this parentheses, or if we remove the parentheses after the O, it will also give this answer, it will also be valid. In this example here, we remove this this closing parentheses because it doesn't have a pair closing parentheses in its counterpart. And we have both parentheses opening in the opposite direction, therefore we return an empty substring, which is also valid. So pretty much make sure every closing open bracket or open parentheses has a closing parentheses within a valid number of parentheses within a parentheses string. So the size of the length of S is between 1 to 10 to the 5, and the index I of the string S is either a open parentheses, close parentheses, or a lowercase English letter. And that's pretty much it. Let's see, there's some hints here. Prefix, open number parentheses equal or greater, some prefix idea. Check the array from left to right. And you mean property, then the same idea as a backwards way. So those are some good ideas. So the first thing I want to do is, how about we convert the string into a list, and then we use a stack to kind of keep track of the matching parentheses pairs. Alright, let's go about doing that. And let's cover a brief idea. So let's say we put string S into a list, and then we make a stack. And the stack is going to basically, we're going to append our open parentheses and pop our, if it's an end. So how about we iterate through each index for each for each index I in the range of length of S, we are going to find if the string at index I is equal to an open parentheses, then we are going to append the index I, or append the character I. Else, if the character S string index I is equal to the closing parentheses, then what we could do is that we could, so if it's closing parentheses, we could do two things. Either if the length of the stack exists, so we have something already inside the stack, and then we could pop it from the stack, right, if it exists. Else, that means that in this case here, the stack doesn't exist yet because there's nothing inside. So therefore, the end closing bracket does not have an opening bracket pair. Therefore, we assign the string at index I to be empty. Alright, that's pretty much iterating through each index in our range of the length of string S. We find open parentheses, we append it. If it's not, then it's closing parentheses. And if the stack already exists, that means there's already, for every start, there's an end that we pop it off. Else, we just assign asset index I to be an empty string. And then what we want to do is exit this loop. And then we do another loop for index I in the stack. What we do is string index I, assign that to be empty. And then we want to basically return the concatenation of S, essentially, with the join. So s.join S. Alright, let's see if this works. Looks legit. Space complexity is big O of n. For the for loop here, big O of n, and big O of n again, so it'll be big O of 2n. However, just call it big O of linear time. And memory complexity is big O of n, where n is the size of S, because we do this join of the stack. Of the list, I mean. Alright, that is all. Have yourself a great day, guys.